we're going to talk about the formula for the area between polar curves right now. So we've already learned that the area inside one polar curve, right? So the area inside a single polar curve is the integral from alpha to beta of 1/2 this r squared d theta, right? So when we want to find the area between two polar curves, what we're going to have to do is essentially, well, I'm going to show you the formula and then we'll walk through where it comes from. So the formula for this blue area, the area between these two polar curves, is going to be that the area is essentially the integral from alpha to beta, right? From the starting angle to the final angle, right? Of 1/2, and we're going to do, I'm going to call this guy R1, and I'll call this guy R2. In this situation, R1 is my bigger quantity, so it's going to be 1/2 of R, well, I don't like the parentheses. I'm not going to do it. 1/2 of my R sub 1 squared minus 1/2 of my R sub 2 squared with respect to theta. So I labeled them 1 and 2. You could also use like an O and an I if you like it better, and maybe that's the smarter way to do it. I'm going to use R sub O for outer and R sub I for inner here, right? The big thing here is that it's the outer radius minus the inner radius, right? So it's the outer radius quantity squared. Now you might say, okay, well, why does it look like this? Well, what I want to point out is that this is actually the same as doing the formula we learned in a previous video for each of the two areas, right? The big area would be my 1/2 the R sub 0, meaning the outer R quantity squared, minus the little area would be the same thing if I did the little r squared, right? The little R sub I quantity squared with respect to theta. So essentially what we're looking at here is, if you picture it, this area, right, would be the full big slice of the pie, right? This whole slice of the pie. And then this area would be this little slice of the pie. So if I were to subtract this little slice of the pie, right, if I took this whole big area and subtracted the little slice of the pie, then sure enough, what I end up getting is the area that I'm seeking, which is the area from here to here only, right? So that's why our formula is the 1/2 the outer r squared minus 1/2 the little r squared. Now sometimes you'll see this formula with the 1/2 factored out, and there's nothing wrong with that, right? 1/2 the integral from alpha to beta of the outer r squared minus the inner r squared, and there's nothing wrong with that with respect to theta. The one word of caution I want to give you is that the r's are individually squared. It is not r minus r quantity squared. The r's are individually squared.